Hello everyone, I Syed Nawaz. Welcome back into my YouTube channel Petrol Universe after a long back. So today in this video we are going to discuss some numerical problems which appear in Anna University semester end exams. That too especially for reservoir engineering one subject. So the numerical question what we are going to see today is yes. So the question is, a gas well is producing a natural gas with the following composition. The following composition is like the component for CO2 means carbon dioxide, the mole fraction is 0.05 means only 5%, C1 0.9, C2 0.03, C3 0.02. And after that he have been asked us to find out the first is apparent molecular weight and the second is specific gravity. Then later on he asked to identify gas density at 2000 psi pressure, and the temperature of the reservoir is 150 degree Fahrenheit, and the specific volume at the same reservoir condition. So before we go for numerical problem, let us see what are the formulas that we are going to use in this question. The first formula what we are going to use to identify apparent molecular weight is nothing but the product of the mole fraction of the component and molecular weight of the component. And the next formula is specific gravity, that is apparent molecular weight of the gas divided by the apparent molecular weight of air, which is 28.96. Later on, density of a gas at a given condition is like Pm by RT, means pressure, molecular weight, what we have identified as an apparent molecular weight, divided by universal gas constant and into temperature. Okay. Then after the specific volume, we have to identify at a given condition. That will be a reversible formula for density of a gas, that is RT by Pm. So we can say that the specific volume is inversely proportional, in this term inversely proportional to density of a gas. So let us jump for numerical problem. So over here if you see, first we are going to identify the apparent molecular weight. Over here we have the components that I already shown you in the question, that is CO2, C1, C2 and C3. So if you remember, then methane, ethane and propane will also have an hydrogen molecule, but usually we don't write. So C1 means it will have an H4, which is nothing but we can use the formula as CN H2N plus 2. So if I am substituting 1 over here, then it would lead to C1H4. Similarly, it will be same for C2 and H6 and C3 and H8. And I have mentioned the respective mole fraction of different components. So over here the carbon atomic number is 6 and oxygen is 2. And we have 2 moles of oxygen here. And similarly carbon is 6. 6 is a carbon number. So 6 into 2. Similarly 6 hydrogen atoms are there that I have to mention over here, but I didn't mention. So let us continue over here, that 6 hydrogen atoms are here, and also 8 hydrogen atoms are here. Okay. So now when we come for molecular weight, so the molecular weight of the carbon, as we know that it will be 12, and in terms of oxygen, the molecular weight of the oxygen is 16, but we have 2 moles of oxygen. So that's why what I am doing is I am just multiplying 16 into 2, which will be 32, and the sum of these two will be 44. Then similarly for methane, what we are doing is the carbon molecular weight will be 12 and hydrogen molecular weight, although it is 1, but we have 4 hydrogen atoms, so that's why I have mentioned over here as 4. So 12 plus 4 is nothing but 16. Similarly I have followed by C2, C2H6 and C3H8. Now here comes the how to find an apparent molecular weight. As you already seen, the apparent molecular weight formula is nothing but mole fraction into molecular weight. So over here if you see, I am just considering the mole fraction of carbon dioxide, right? So that is nothing but 5%, which is 0.05 into the molecular weight of a carbon dioxide, which we have already found, that is 44. So once I perform the product between this, then the final answer is 2.2. Then similarly for C1H4, which comes around 14.4. Final apparent molecular weight after the summation of these values, 18.38. So let us jump for the next term. What we have to identify, we have identified the apparent molecular weight, which is 18.38. So now over here we are identifying the specific gravity. As I shown you in the previous slide, how to identify the specific gravity, which is apparent molecular weight of a gas, what we have just found out, and the apparent molecular weight of an air, which is a standard value as 28.96. 18.96. I'm just simplifying this ratio, means 18.38 divided by 28.96, which will be 0.6346. So now I am going to calculate the density of a gas at a given condition. So the density of a gas is Pm by RT. Means pressure is over here, it is 2000 psi, and the apparent molecular weight what we have identified is 18.38, and universal gas constant, as you all know, that it will be 10.73. and apart from that the temperature is 150 degree Fahrenheit. But over here when we are using the temperature and density of gas formula, then it should be in terms of Rankine. So to convert from degree Fahrenheit to degree Rankine, we have a unit conversion as 460. So 150 plus 460, it leads to 610 degree Rankine. So once I simplify this, I got an answer as 5.616. And after that, as I already told you, the specific specific volume of a gas will be inverse value, okay, like 1 by density. If you clearly see the formula, which is RT by Pm. So what I have to do, I just have to 1 by 5.616, what I just got as a density of a gas. So finally I will get an answer as 0.178 feet cube per LB. So the one point that I would like to tell over here is, they have given this question in various marks distribution. Like if you are finding the apparent molecular weight, then they have given this apparent molecular weight for 3 marks, okay, and this specific gravity they have given for 3 marks. Similarly, they have given this gas density for 3 marks only, and specific volume they have given for 4 marks. So that's the end of today's video. Let us meet in the next video. If you have any sort of questions that you are unable to solve, and so you can text me up in the comment box, so I will make a next video on that. Thank you so much. Have a nice day, and subscribe to my channel if you haven't subscribed yet. Like this video and share it to your friends who are from Anna University or any other college who are appearing for reservoir engineering and who have such kind of problems. So have a nice day. Bye bye. Thank you.